this video, girls, we'll go through the homework that I gave you last lesson. So what I'd like you to do is I'd like you to watch the video. It's a tricky question, it's a really tricky question, but I'd like you to watch the video, make sure you write in the correct answers to anything you got wrong, and don't be afraid to put a message on the chat if you have a question on anything that I've gone through. So, first question is, in 2019 marks the 50th anniversary of hang on, I need to add notes here, it is, 50th anniversary of man's first landing on the moon. Since then, there have been a number of other missions to the moon. The diagram below shows the Earth orbiting the Sun. Complete the diagram to show the shape, location, and motion of the moon. Now, it's important that you include all three of those because actually there's marks for each one of those. Hang on, can I make this pen a little bit thinner? I can't. Well, first of all, the shape. So the moon is circular. Its location, so if you drew a circular moon, you get 3 marks. Its location is that it's near to the Earth but far away from the Sun. So your moon has to be closer to the Earth than it is to the Sun, and that's another 3 marks. And then its motion is that it orbits the Earth, and that's the final 3 marks. So make sure that you've done all 3 of those because you don't get full marks unless you do all 3. Next section. At the time of the first landing, the moon was in a waxing crescent phase, as seen from the Earth. So remember, the phase of the moon crescent is when it is, you can only partially see the moon like that. And the opposite of a crescent is where you can kind of see most of the moon, but not all of it, so I'm a terrible drawer here. Something like this, but you can just see the bit on the left there, and that's called the gibbous. So in this one they're asking us that a waxing crescent phase as seen from Earth. The images below show different phases of the moon in sequence from left to right. Place a tick in the box beneath the image that shows the moon in a waxing crescent phase. So that's going to be that moon there. That's the waxing crescent. Next, and that was worth 3 marks. Next question. Shade in the image of the moon on the left to illustrate the next phase of the moon. So the next phase of the moon, as you can see here, it's getting darker from left to right, or you could say it's getting brighter from right to left, getting brighter and brighter, brighter and brighter. You're seeing more of the moon as we go from left to right. So the next phase will be as the darkness starts to come from the right. So what we'll see is the moon will now start to become shaded here, and we'll have what I just mentioned was a gibbous, and that's worth 3 marks. Next question, part C, was really tricky, and we did mention this in class before, but it's really hard to explain over a video. I kind of need to show you the little models we have in class to kind of explain it, but I'll try to explain it. So on January 2nd, 2019, the Chinese Chang'e 4 lander touched down on the far side or the dark side of the moon. Explain why this side of the moon is never visible from Earth. So to explain this really, and it's quite tricky as I said, can I move this down a little bit to get a bit of space? We're here on Earth, and the moon orbits the Earth, goes around the Earth like this. When we look at the moon, we always only see one side of the moon. And that's because as the moon goes around the Earth, it's actually spinning as well. So if you notice here, this side of the moon, the side that's visible to the Earth, is now not facing in the same direction. Now it's kind of facing down a little bit. Here it's kind of facing down and to the left. Over here it's facing down or to the left, whereas here it's facing to the right. So what is the moon actually doing there? Well, it's actually spinning as well. It's actually spinning on its own axis. And it just so happens that the speed at which it spins matches exactly the speed at which the Earth spins, or the rate at which the Earth spins. So your answer for this one is that the moon spins on its axis, and that's 3 marks. So the fact that it's spinning means that that same side of the moon is always facing the Earth. But you do want to get, for full marks, you do want to mention that it is at the same rate as it takes to orbit the Earth. So it's not spinning at the same rate as the Earth is spinning, but it's spinning at the same rate as it takes for it to go around the Earth. And that's the second 3 marks. So that was a really tricky question, but that one could come up again. So I definitely think you should add that to your notes if you don't already have it clearly in your notes as a model answer, as an example answer. Next question is a little bit easier, and it's one of your definitions you should know. What is an asteroid? It is a clump of rock that orbits the Sun. And 3 marks if you got that one correct. Oh. Next question. Many investigations were carried out on the surface of the Moon during missions to the Moon. One investigation measured the temperature of the lunar surface at various depths. The graph shows the temperatures measured at different depths. So we look at the red line first. So the red line is the temperature of the surface of the Moon. And what we can see is the temperature starts here, but as time goes on our x-axis we have time. So as time goes on, the temperature gets bigger and bigger and bigger. And then it starts to go down again, lower and lower and lower, bigger and bigger and bigger. So obviously the temperature is getting bigger and smaller every day, or every couple of days, or every 5 days, depending on what way you read this. So describe how the temperature of the surface of the Moon changes with time and suggests an explanation. Now again, where people lose marks here is they don't read the question carefully, because there's 2 bits to this. Part 1 is describe how the temperature changes, and part 2 is suggest an explanation. And if you don't answer both of those parts, you won't get full marks. So for describing the first bit, we could just say the temperature increases and decreases, and that will get you 3 marks. But even better, you could say in a regular pattern, because it's going up and down and it's very regular. Part 2 then is suggest an explanation. Well, why might it get warmer, colder, warmer, colder? Well, if we think of what happens on Earth, why does it get warmer, colder over any 24-hour period? And it's because during the day we're in direct sunlight, it's warmer, and at night time when the sun isn't in our view, or where the sun goes down, it gets cooler. So an explanation might be warmer in direct sunlight, cooler when not. And that's the second 3 marks. So 3 marks and 3 marks, but it's really, really important that you understand that there's 2 parts to the question. Next bit, describe a relationship between the depth below the surface of the Moon, the depth below the surface of the Moon, and the change in temperature, and then suggest an explanation. So again, there's 2 parts here. There's the describe part, and then there's the suggest an explanation part. So let's have a look. Well, what's the difference when we go deeper and deeper below the surface of the Moon? So on the surface we have this red line, but as we go 15 centimeters below the surface of the Moon, or 30 centimeters below the surface of the Moon, you can see that the line doesn't go up and down as much. So that's our explanation. That's our description of what's happening. So describe what's happening at greater depths. So the deeper you go, basically, there is a smaller change in temperature. The temperature doesn't go up and down as much. I'm just going to write in temp because I haven't much room. So that's 3 marks. But again, we have to suggest why this might be, and this is the trickier bit. So why might that be? Well, I suppose the deeper you go, you're kind of insulated by the soil that's on top of you, and we've talked about insulation and heat before. So you could say that deeper levels are insulated by soil above, so not exposed to extreme temperatures. And extreme is the word we use just when it's saying that the temperatures are really, really big. And I'll give 3 marks for that as well. So that's a tricky one, the last 3 marks. Last question. The diagrams show the mass and weight of 4 objects A, B, C, D on Earth, and these 2 are on the Earth, on the Moon, and on the Earth's Moon, Jupiter and Venus. On the Earth, Earth's Moon, Jupiter and Venus. Oh sorry, so this is the Earth, this is the Earth's Moon, this is Jupiter, and this is Venus. Which object A, B, C or D has the smallest mass? Well, remember, mass is measured in kilograms, and in the last homework quite a few of us were getting that wrong, so mass is always measured in kilograms. So the smallest mass would be this object here, because it only has a mass of 1 kg, whereas this one has 3 kg and the other 2 have 8 kg. So it would be block or object C, and that's worth 3 marks. How can you tell that the force of gravity is less on Venus than it is on the Earth? So we're only looking at the Earth example and Venus example. Now we're able to compare these, and the reason we're able to compare is because both objects have the same mass. So they both have the same mass, but the force is different on Earth than it is on Venus. And you notice that the force is bigger on Earth. It's 80 newtons on Earth, whereas it's only 72 on Venus. So how can you tell that the force of gravity is less on Venus than it is on Earth? There is a smaller, and we'll call it gravitational force. You could call it weight on Venus, but it's really, really important that you include in there for an object of the same mass. So that same mass bit is important as well. And that question was worth 3 marks again. And the very last question, the hammer and feather were dropped at the same time from the same height and hit the surface of the moon at the same time. A hammer falls much faster on Earth than it does on the moon. Why? Well, on Earth there is greater gravitational force, so objects fall faster. Okay, hopefully that made a bit more sense for you. Make sure you can pause the video if I was going too fast for you, and you can go back over certain things. And don't be afraid to ask me any questions about any of the work.